We've got a lot
Yeah,
of people here from around the world, and here we are.
yep.
Tell us about
Let's
it.
begin. Welcome, everyone. Welcome to the Tracing Frontend Issues with Backend Solutions workshop. Hello, YouTube, if you're tuning in from YouTube. Hello, Zoom, if you're tuning in from Zoom. I see 115 of you in Zoom right now. I'm not sure what's going on YouTube, but it must be fun there as well. So, yeah, welcome, everyone. I think it's going to be a really good workshop. We have something cool prepared for you today. And yeah, before we begin, a little quick housekeeping. There's not going to be a Q&A. For example, if this is not the first time you're tuning into one of our workshops, we usually do a Q&A at the end of the event, but we decided to make this super casual. And we'll just, we'll just talk. We'll just keep an eye on the chat. We'll see a question. We'll try to answer it right there on the spot. So no Q&A at the end. Yeah. And also, we will send you a recording. If you're registered in Zoom, you're going to receive a link to the recording. As you know, as we mentioned, it's already a live stream on YouTube, so you can just go and Sentry's YouTube channel, and you get to see a preview if you miss it. But yeah, that is really cool. Let's introduce ourselves. My name is Lazar Nikolov, and I'm a DevRel here at Sentry, and I'm going to be one of your hosts today. Hey, Salma.
Hi, I'm just finishing up a message here. So I'm Salma. I'm senior DevRel at Sentry. I have had a very varied career, lots of different experience across tech and different things as well. I pivoted to tech in my late 20s from music and teaching, and since then I've been a front-end dev, tech lead engineer, always a front-end specialist though. And I'm here to teach you about some stuff today as well.
Nice. I was also a musician back in the day. That's like a recurring pattern, I think.
Yeah.
People
Yeah.
with coding and music, it like goes hand in hand. If you're not learning music, maybe you should start, join the club.
Yeah.
But I have a question for Salma. Because this is you mentioned that you were predominantly front-end engineer always. So given that this workshop is tracing front-end issues that were caused by back-end issues, have you been in a similar situation where you had to fix something on the front end, but the solution was actually in the back end?
Yes, and it still continues to haunt me. So years ago, I was working for a company that doesn't exist anymore that was building a mobile app, and it was to do with energy utility switching. And the front end was React Native, the back end was Go and Ruby, different APIs for different things.
Interesting.
Now, the CEO said one day, login is taking 20 seconds. It's a front end issue, please fix. And so, well, like, it's not as if we've got like a sleep on the login button that's waiting 20 seconds. So we needed to find out what was wrong. Now, we didn't have Sentry across the full stack back then. We only had Sentry in the React Native application. Nothing was showing up. And obviously Sentry many years ago was very different to what it is now. So we were using Prometheus and Grafana data to try and figure out what was wrong. And we noticed a few HTTP requests that were kind of taking a bit too long. So we looked into the code, and it turned out that the login function was looping through every single published app version to decide which version of the API from the backend to serve for the app and the login and everything. And it was written so terribly that it took 20 seconds to go through all the app versions. We fixed it. Yeah, we fixed it by rewriting the Go code and showed the graphs go down. Everything was great. But the CEO still insisted that it was a front-end issue. And whilst we'd fixed it, he didn't celebrate the fact that we'd fixed it. And so this is why we need this kind of data and this kind of tracing view to make our case. I mean, it's not a big deal that we were still blamed because, whatever, everyone's on the same team. But at the same time, it would have been nice to have some recognition that we as front-end engineers went into the back end and discovered this solution, and here's what it was. And what could we learn from this now, in the back end, and how could we not replicate this in the future? So that's my story.
That is the most suitable story for this workshop, actually.
Exactly.
Yeah, so for those of you who are watching this, maybe you've been in a similar situation, right? So in this workshop, we'll learn how to handle those issues, how to handle those scenarios. All right, yeah. Thank you, Salma, for the story. First, let's talk about the agenda. So we're gonna start with a tracing 101, just so we're all on the same page, right? It's gonna be like 5 minutes. Then we're gonna see how to set up Sentry in a React and Node.js projects. It's pretty much uniform across all the frameworks. We're gonna see a demo of tracing. We're gonna see traces in Sentry. This is a brand new thing that we're releasing today, a bit later in the day. Then we're gonna look at some of the insights modules that are, supplementing tracing in a way. And then we're just gonna do a wrap up at the end. How about that?
Sounds
Awesome.
good. I'm gonna get off camera while you do your bit right now. See you in a bit.
All right, so let's talk about tracing. So tracing is a powerful debugging technique that allows you to track the flow and timing of all of the operations, all of the requests in your application that not just happen, that are not just limited to the backend or front end, but across your whole stack, right? That's why it helps you debug across different projects. You have a front end, you have a backend. Maybe your backend is a microservice architecture, so you have multiple projects for the backend. Yeah, tracing allows you to debug across all of them, and it's especially useful for full stack and microservices. Because it captures debugging data with a start and an end. You'll see later. It helps you, and it visualizes in such a way that it really helps you identify any performance bottlenecks that you might have in your application, whether they're on the back end or the front end. And of course, bugs like race conditions, N+1, caching issues, you can't really debug those with just logs, like console logs and stack traces. You need to see the whole call chain in order to understand what is going on. So tracing is really important, in these more complex and weird bugs that occasionally all of us, unfortunately, have to deal with. So I want to take a few minutes to deconstruct tracing, so you see and understand the concept of tracing. So let's say that we have console logs sprinkled across all our project, right? And let's say that we have these log messages sent to somewhere, right? So we can, read them later, even though if they're in the backend or the front end, doesn't matter, right? Imagine if you have like 100 or 1,000 or 10,000 users, that log stream is going to be a mess, right? Everyone is going to use the app, produce these log messages, and it's just going to be a huge hot mess. If you want to debug a certain bug, let's say a user reported that the checkout flow actually errored out, you can't really see all the message, the bug or the error in the message log. So you have to somehow identify it, right? You have to put an identifier to those messages. Let's say that this is the user, and at this time, they're triggering the checkout flow for the e-commerce website that you're working on. Let's assign that ID to that operation flow. So all of the messages that has to do with that user's operation flow will be prefixed. That would work, right? In a way, that is what a trace is. A trace is a collection, is a way to tie together multiple, I'm not going to say log messages, I'm going to say debugging information, not just log, because log messages are debugging information, but we can do more than just log messages, and you'll see. That is what basically tracing is, a way to tie in and just like pull out debugging information in a specific order from a heap of data, right? And traces usually start where the flow starts. If the checkout flow starts on the front end, then the trace is going to start at the front end, right? That's when we either visit the checkout page or we hit the checkout button, etc. that's where we define the trace, right? That's where we start the trace. And we mentioned log messages, right? They, in a way, they mirror our code. We can say console log start of this function and then end of this function. And then we call a different function. We can say console log start of that function and then end of that function, right? Just so we can see how, how the operation flow goes into all these functions. So let's define that. But instead of a message, we're going to call these spans. Spans are the smallest unit of work, right? And they will describe everything that whatever the operation does at that specific moment. And because we mentioned like function start, function end, we can also put timestamps so we can do the math and see how long it took. Let's just say that spans will have some data attached to them. And the first span is actually going to define the trace, and we'll call that root span, right? So smallest unit of work, they have some data, like some little storage attached to them. And the first one is the root span. Because we have data now, we can attach data to each of the spans. And imagine that spans are like classes, classes with start, with an end, with some data, with an operation, a name, right? And we can basically sprinkle spans across our application, and that's going to mirror the code base. That's going to mirror where the execution goes, and we can also see the spans get created according to that. Because we have a start and an end, we can visualize them with like a certain width based on a timeline. Because one span can create another span, right? We can chain them. We also have a hierarchy now, right? And this all helps us, define or just like mirror our code base, right? We have the hierarchy, we have the contexts. The context is like the little span storage. And we have the trace and we have the parents. So now, because this technically is a Gantt chart, we can see which span took longer than we anticipated, right? Because if this span is for sorting data and it takes the longest, or it's the biggest span of the whole operation, and we know that there's a slowdown issue in that, then we can clearly see that the issue is in the way that we're sorting the data, right? That's the killer feature in tracing, because we can visualize them and just look at the answer will just jump out. We're using a Gantt chart, of course. And aside from that, we can also append tags. We can append any arbitrary metadata so we can search for them later. Imagine that we have a whole database of spans, and we tag the sorting spans with a certain tag. We can say, give me all the spans that have this tag and show me how long they took. So you can see the distribution based on a specific span with a specific tag, right? This way, we really don't need any log messages now. We can store any debugging information that we want in the spans themselves. But how do we move the span, the trace from the front end to the back end? Well, spans have their IDs. The trace itself has an ID, right? We mentioned at the beginning that when the operation flow starts for that user at that time, we'll just generate an ID, assign it to it. That's the two IDs that we need in order to pass it through the next service or the next operational logical unit. For example, in this case, it's the user's service, right? We can concatenate the trace ID and a span ID into a string and move it through, let's say, HTTP headers. That's how we distribute the trace. Now on the user service, when the user service sees that we already have this header, it'll just be like, okay, there is already a span. I'm going to create my own root span, and I'm going to set that root span's parent span to the one that we have from the headers. So I can continue the trace. And as long as it's a string, as long as we can pass strings, not just through HTTP headers, but anywhere, we can basically instrument our whole tech stack. So we're not limited to just the front end, right? That is, in a way, distributed tracing. And yeah, I hope the concept, I hope you understand the concept now. And we can, and that was a breather. I'm going to take a breather now because that was a lot. I'm going to let Salma tell you about how to set up Sentry in a React application now.
Yeah, so we also did have a question in the chat related to this. How do we configure distributed tracing between a React app and a Ruby app? And the fact is that with the newer SDKs, it just happens because Sentry is always sending that trace ID and the span ID headers across the internet, across HTTP. And so things get connected inside the Sentry app. So if we go now, Lazar, let's go to Sentry for React. So it's as straightforward as installing the Sentry React SDK with your package manager of choice, and then configuring your Sentry installation and initializing it with a DSN, which stands for data source name. After you have signed up to Sentry and created a new project in Sentry, you'll get your DSN, and you just got to put it in your app. Usually you might put it in your app as an environment variable. With React, make sure to make it a public environment variable, or if you're using a meta framework, some environment variables are public and not public, but it's not a sensitive piece of information. So you can expose it, but generally you'll put it in an environment variable. And that's how to set up Sentry in a React app. Now, there are other configurations and other options that you can use to extend the experience, but you get tracing inbuilt by default without having to install any other packages or integrations. And you can configure what we call the traces sample rate, which is how many events will be sent to Sentry. And obviously you want to probably put that down to maybe 50% or lower in production. So that's your Sentry configuration in React app. And then we go to the backend. And it's a similar kind of thing. Say if you've got a Node backend, it will be the same for Ruby as well. You install it via a package manager and you initialize it with your DSN and configure it how you need. And obviously there are plenty of specific configurations for you across the front end and back end use cases. On the front end, for example, we've got things like session replay, which we'll get to. And there's even user feedback as well, which is a front end integration. So plenty of things to look at on our docs. And really, it's just adding a few lines of code to each of your applications in your architecture, and Sentry automatically connects everything for you. Awesome. So the links to those are in the Zoom resources section as well. And I think I want to ask Lazar, I want to take a look at what you've been working on the front end, what you've been debugging lately, Lazar.
Yeah, so check this out. We have this really cool futuristic application, e-commerce site that sells high-tech plants and stuff for gardens. For example, we have a plant mood, we have a Botswana voice. It gives a voice to your plant so you can talk with your plant. We also have a bot that takes your plant for some sunshine and brings it back. And we also have plant nodes with Sentry built in so you can monitor the soil and everything. And there's an issue. We've been receiving some Twitter messages about, the products page being slow, and we can see this slowdown clearly. And one user tried to buy $1,000 worth of the Botswana voice because they wanted to build an orchestra or a podcast using plants. So when they actually went to check out through the checkout flow, they actually noticed that it didn't actually happen. They weren't let to check out the cart. And as a user, what I would do in this case, I can report a bug using this button right here, which will send a message to the developers, me, so to understand what is going on and to actually fix the error. Or I can just click on the Contact Us button because it's here. But nothing happens. I keep clicking it. Okay, so
everything's broken, Lazar.
Yeah, there's a lot of issues. Yeah. Okay, so yeah, let's say that I was smart and I'm not failing during my demo. But actually, I've set up alerts for my Sentry application. And those alerts are actually letting me know in Slack when bad things happen. So check this out. This is my Slack channel where Sentry lets me know of every little nasty thing happening inside of the application, right? So we can see a rage click, and Salma's gonna talk about that later. A rage click is when I actually spammed clicking the contact us button, but nothing happened. And we can also see an internal server error here, which is presumably when I try to check out the page and the error happened. So to me, this is a really cool shortcut because I can just click on error, click on the error itself, and I am taken, oh, let's go back to this screen. And I'm actually taken to the exact page in Sentry. Hold on, let me bring back my UI. There we go. So I can see what the actual error was, right? It was a 500 internal server error. Let me know if I need to zoom in. It's really big on my screen right now.
Yes, zoom in, please.
There we go. And I'm also going to hide the bar so we have more real estate. Okay, so this is the issue details page. This is not the tracing page, right? But love that it captures rage clicks. Yeah. So when an error happens, Sentry lets us know with any sort of alerts, whether it's email, whether that's a Slack message, whether that's like a Discord message. There's like a ton of integrations you can use to let Sentry, enable Sentry to reach to you when an errors happen. So what we can see from this screen is that the general grouping of the error data and the error data, the individual error data itself. So we can see that 7 events happened from this issue, from the 500 internal server error that affected 7 users. In the last 24 hours, we've seen 4 of these, but in the last 30 days, there's been 7 of these, right? So yeah, the first seen label says 15 days ago, and that pretty much tracks because that's when we actually pushed the release. This one, the 24.6.1, and we can see that the last has been 3 minutes ago, which was me clicking on the checkout flow. Aside from that, we can quickly create a linear issue or a Jira issue or whatever integration we have. We can see all of the tags, distributions for this specific issue. If, for example, the customer type is an important factor for you, for example, if they belong to the small plan, maybe the priority is going to be low, or if they belong to the enterprise, you would wake up at 12 a.m. to fix it. That's on
All
you.
customers are important, Lazar.
I'm just giving an option, Everyone works differently. So yeah, these are custom tags that we defined in the app. And if we scroll all the way down, we can see the whole context. We can see all of the tags. And for example, for this specific plan, for this specific issue, we can see the customer type is set to small. So you know what? I'm going to look at it later. But aside from this, we have the stack trace that tells us where in our code base the error happened or the exception. We can see throw new error. This is the line. It's in the component/checkout.jsx. That tracks. We were at the checkout screen on line 76. There's the Sentry metrics incrementing that the checkout error happened. We can see a window in the codes. And we also see red lines here. And those are by the CodeCoff integration saying that, these lines are not covered using tests. So maybe we should have written tests for this. Maybe this error wouldn't have happened. That's something to know, right?
See, Sentry helps you also become a better coder, a better developer, a better tester, and a better human.
Exactly. Yeah, so aside from that, we also have a little window called session replay, and Salma's gonna tell you all about this later. But this is in a way a recording that lets you see what the user did while before and after the error actually happened. There we go. You'll see that later. But let's say that this is an easy bug. We can see, oh yeah, this error shouldn't have happened because this and that. You know what to do. You'll just go back into your editor and fix the bug and push a little patch. But maybe this is a more complex bug, like we mentioned the ones before. Maybe this is an N+1 or, any kind of complex issues. In that case, you want to see the whole operation flow, and we can easily do that by clicking on the View Full Trace button right here. So a trace has been captured. This error belongs to that trace. It lets us see the full trace. And does this look familiar? Like maybe one of the previous slides before. Yeah, these are the spans that I was talking about. And the trace started on the front end. As you can see, this is our React project. And our React project initialized an HTTP client post to this API, which is our Flask Python backend. And if we click on the plus button, we get to see what the backend did when we actually clicked on the checkout button. And we can see that the...
Sorry, I thought you'd stopped. I have a quick question while we're on just this very big tour of the trace view. Yeah. Is root span the same as transaction mentioned before?
Yeah, transactions are a Sentry specific thing that lets us just grab the data and push the data to Sentry. But spans are, like individual to by themselves. They're not the same, right? The transaction has an ID, but it has nothing to do with the root spans ID. They're not the same ID. So yeah, totally different things. The transaction is just a vehicle to grab the data from from the collector, from the SDK, and send it to the DSN link that you provided when you set up Sentry. So that's transactions. Yeah, but in this case, we can see the trace. We can see everything that happened. For example, we went into the checkout. We can zoom in, and see all of the things. We went into the get inventory function. There's a timing metric on the actual execution time for the get inventory. We can see that we did a DB connect operation right here. It took 0.10 milliseconds. Then we did a DB query that took 4 milliseconds, right? And the query was this: select everything from inventory where product ID in 4, right? So we're pulling data from the database. This is the query. That's how long it takes. We can see the whole span tree right here. But the most important thing is that we can see, aside from the submit checkout form being read, we can also see that the HTTP server is read. That means the HTTP server reported an error. And if we click on that, we get to see the error in the right-hand side, which is not enough inventory for a product. Okay, so realistically, we can't build a podcast just by using plans, no matter how, if we spend $1,000 on them or not. So, but this tells us that some team, whether the backend or the front end or us, I bet it's us, we're not handling the inventory check. We're not doing inventory checks before allowing the users to actually check out their carts. And this is just an ordinary exception. If we click into it, we get to see, oh, there's a suspect commit. Maybe this commit introduced the changes that, triggered this error. We can scroll down. We can see there's the exception, right? And this is a Python file. So it's in source/main.py on line 120. Now we're into the backend. Now we're into the Python code. We're looking at the stack trace. We're looking at what the cart has been, the data that's been received. We have access to everything. And it's even accompanied with a session replay because it belongs to the same trace. Even though it's a backend error, we can see what happened on the front end when the backend error happens. Because maybe sometimes you don't get to see front end and respond with an actual error, but the backend through the error. So this is when you get to see what happened on the front end when the backend error happened, which is really cool. Okay, so
bringing it back to, is this a front end issue with a back end issue, front end problem with a back end issue, or like what's the deal here? And I said earlier that Sentry helps you become a better developer. And I think this is one of the areas that it can help you actually become a better architect of your systems. Because whilst I don't want to solutionize too much to how we should deal with this error, it does show that it's an issue across the full stack. The front end should be checking for the inventory when you're adding something to your cart. The backend should provide an API for that, or it should happen at a different time. And so we've been able to use this whole tracing view and all of the spans put together to diagnose that something's not very good. And we might not have known that it's not very good, especially if the backend and front end teams don't speak to each other, because sometimes you don't. And so it's like it speaks to building better, more stable systems. Now, we do have a question that's quite related to this from Nick Taylor. If I were testing an onboarding flow, would a transaction make more sense than a span? And I don't quite know what you mean by this, but I think this leads me to talk about actually why you would use Sentry and traces. And it's not a product analytics tool. The tracing and the whole approach to using it to debug and diagnose things, which I'll get to in a minute, is about your internal systems and not about what your users are doing and that kind of data. So testing on an onboarding flow sounds like you might want to count how many steps someone has done. And it's kind of like not really belonging in Sentry, that kind of data. So I hope that helps. We do have a couple of other questions, but maybe we could get to some of these questions actually before I move on to my bit. How does Sentry handle unhandled errors, Lazar?
Even unhandled errors have to, eventually bubble up and blow up somewhere. Sentry will capture that if you have the SDK already set up. And they'll send you an email, they'll send you a Slack message, whatever you defined. So yeah, it's always gonna, capture those kind of errors. That's by default.
They're the best errors that Sentry does capture, because you need to know when your errors are unhandled.
Those are the unexpected ones.
Yeah.
Yeah. You can even capture handled errors as well manually. There is a Sentry, an API, Sentry.captureException. You can pass the exception itself when you catch it in your code base. So even though you've handled it, even though you let your user know or send them feedback on the screen, this is the, we don't have that many Botswana voice pods for you, you still want to know about that. You can even manually capture them. So automatically, those are automatically being captured, but you also have the option to manually capture errors, the ones that you handled.
And we have one more question, which we'll reiterate. So someone asks, the trace has an ID. How should we pass the ID to the backend to keep the connection? Sentry does it all for you via HTTP headers. So you don't need to do that manually. It's just done for you. So you don't need to worry.
Exactly, yeah. But if you have to manually pass it, it's literally the span ID dash trace ID. Or was it the other way? It was the other way. But yeah, trace ID dash span ID. There's like a third value, a 0 and 1, to indicate whether that's being handled or not. But if you make that string yourself, you can just pass it anywhere you want. And the trace is going to, the next service is going to be able to continue the trace.
Thank you. So we've got two more questions. I'm going to answer one now, and then the next one is going to segue really nicely into the next section. So the first question is, do both the front end and back end need to be using the same Sentry project and DSN for the trace correlation to be done automatically? No. And that's the good thing, because you want to be using different projects. Maybe you have a React project or a Ruby backend or a Python backend. You need to keep those projects separate. And especially if you want to configure different alerts for different teams, that's really useful to keep those separate, and they have to be kept separate because of the different SDKs. So Sentry again does it all automatically for you, as long as you've got your DSN for each project and you install Sentry and configure Sentry with that particular project's DSN in your code, Sentry will do it all for you via the trace ID header, HTTP header. And then moving on to the question that's going to go into the next section, how is the Sentry performance monitoring at the front end different from tracing, if at all? So I'm going to answer this basically now. We're going to go and have a look at the performance side of the product and how tracing is connected, because tracing is not just for errors and not just for debugging like what went wrong, but it's also debugging what might be slow and what part of a trace might be slow. So if we can go, first of all, Lazar, let's just go to the Web Vitals screen, because of course, every front end needs to monitor their core Web Vitals and their overall kind of performance. So we're going to go to our React project. We're going to have a look at the Web Vitals. So here you've got your main core Web Vitals aggregated here. The scores you see there for things like largest contentful paint, first contentful paint, INP, etc. They're all the P75 values. So those are the highest values that 75% of your users are experiencing on those core Web Vital scores. Now, so underneath there, you have grouped a grouped list of things based on the different routes of your front end. So for example, we've got /products there, and we can see that the overall performance score for /products is a little bit meh. So we can drill into that. We're going to go into that area. Now, this is the overview of /products, but what you see if you go down, you will also see some individual sampled events for the products page. So if we choose like a really bad one, let's go to the poor 49 one, the third one down. This was a very slow page load. And what you see here is a trace view. So this is everything that happened on the front end. Everything is connected again. All of these different spans are connected. And this is just contained within the front end initially. And then you'll see it also move. If you scroll down a little bit, you'll see it move to the back end when it makes that call to the Ruby API and the Java API. So we're now going to look at tracing from a performance point of view. And here we can see the performance of the products page is potentially very bad because of this database query. And it's not a single database query, it's 5 database queries. This is what we call an N+1 issue, where database queries are being done in a loop rather than all at once. And as you can see, the different the timings for each of those database queries, you can see, you know, the longest one was like 1.25 seconds, where product ID equals 8. And so where the performance, I think it was the first contentful paint actually was really bad on this products page load. It's a front end issue because the product page is slow, but actually when you drill down into this trace, you can see that it's because of the amount of database queries that are being done one after the other. And you can actually go further into this if you're interested and actually look at all of the database queries themselves if you want. So if you go into the sidebar again, Lazar, and we can go into the performance area and we can see into insights, we can actually see queries here as well. So again, we have a whole list of all of the different database queries that are being made, and they are sorted by, or you can sort them by the average duration and the time spent. And what's an interesting thing on here is that some of the database queries are really small, but they take a lot of time to be done. So if you sort it, Lazar, by time spent.
Okay. Yeah.
I think there are some, is that done? I think there were some that took like a week or like 2 weeks.
Maybe in this time frame in the last 30 days.
Go to
last 90.
Yeah, go to last 90. I just like seeing how like there's weeks spent on a database query, which is quite interesting. There you go, 1.37 weeks. And the average duration of that is 1.46 seconds, but it's because you're doing 4.4 queries per minute. So you might think, I mean, an average duration of 1.46 seconds is actually quite a lot for a database query anyway, but it also shows how many you're doing per minute. And again, if you look at the third one down, you've got an average duration of 359 milliseconds, but you're doing 13.7 a minute, which is taking a week. So
A
if you really want to,
query.
yeah. And that's the N+1 issue, where rather than grabbing all of the data in one query, it's like doing it one after the other. And so if you're really looking to optimize the performance of your full stack, you could go into the trace view through performance and then find those bottlenecks and then go further down into the weeds, into the queries, and really like looking at the code that's contacting the database. So I think that's a really interesting way to connect it all together. And I think it also really proves that from an architecture point of view, the front end and back end now, these days, they shouldn't be seen as two separate disciplines. They should be, and Sentry helps bring them together and helps you connect everything that's happening. And I think, you know, when as teams adopt this across the full stack and across the whole tracing kind of concept, it brings developers and teams closer together, I think. And it encourages you to communicate more and understand what's happening more. I wanted to just look to see what a couple of questions we had here. So Alexi says, if the backend team already uses OpenTelemetry, could it be connected with Sentry tracing on the front end?
Yes, it can. Yeah, we have an integration with the OTel library. So you can use the OTel instrumentator, and hook it up with Sentry's SDK so that Sentry can send that data to Sentry, and then you can, you know, use all of Sentry's tools to, you know, slice and dice the data as you want and as it makes sense for you. So it is possible. Yeah, I believe we have a few doc site pages that show you how to do that. But yeah, we do have an integration with OTel's instrumentator or instrumenter, I guess, SDKs.
Thank you. And do you have any suggestions on passing that trace or span to the backend when using TRPC? Sorry, my camera's just turned off. Carry on.
Yeah, I guess the same thing. Yeah, you can use Sentry's SDK to, at that moment where you send the actual message through TRPC, you can, that's still HTTP, right? If it's HTTP, the SDK itself is going to automatically do that for you, I think, because it's an ordinary fetch. So when you do a network request, like an HTTP request, it should automatically have that header for you. But you can always use the SDK itself to get the current running trace from the current transaction, and then you can pass on, you know, manually construct the trace context and send it over as like a part of the message.
Yeah. And continuing sending events via Sentry, we have a question. In my user sessions, I log things like microphone permission, audio device changes, visibility changes to help me diagnose when something goes wrong. How do I add this context to the session in Sentry? And you would do that with custom tags. You can just use sentry.setTag, which is a key value thing, and Sentry will keep that in the scope. So whenever something changes on your in your application, you can just do Sentry set tag, and it will automatically propagate down into any of the events that are sent on. It's very clever. I got a demo from one of the SDK team about that. It's far too clever. It's amazing. So you just use custom tags for that. And I'm really sorry if I'm not answering your question from Zoom, because I'm trying to keep them like on topic and not derail where we're going. So is it, well, I will answer this one though. Is it possible to install Sentry on the customer's premises? Is there a separate license? You can self-host Sentry, as long as you don't resell it. We have a business open source license. So obviously you won't
It's
be
our own
reselling it.
license, actually.
Yes, it is our own open source license. So you can self-host it completely. All the code is open source, and you can store your data wherever you need it and you want it. But we are not responsible for your hosted instance, but you can get support from us in the Discord if you need it as well. Okay, next. So I do want to touch on one more thing, because Lazar talked about replays earlier and was very excited for me to talk about replays. So you saw earlier with the error that there was a replay associated with an error. Now, again, story time. As a front-end developer, right? I used to be on call for a week and I'd get woken up in the middle of the night. And I was working for a company that had this huge monolithic Java e-commerce platform system. There were 500 international websites, and it was a minefield, and it was all a bit much. And so when I got a call as a front-end developer at 2 a.m. In the middle of the night, someone can't check out. I'm like, right, so how do I do this? Can you? And then there was all this back and forth about what browser are they on? What have they tried? What website are they on? What are they trying to buy? Etc., etc. And there's me trying to spin up my virtual Vagrant machine at 2 a.m. in the morning, trying to recreate the issue and not being able to fix it, need to call loads of other people. Like, it's not a good experience. But with replays, you don't need to do that anymore. So if you go back to one of these replays, and if you can click into any of them, I guess, maybe one with some errors in. Let's go with the 5 errors.
Okay.
TanExample.com.
This one, yeah.
Yeah. One of the greatest things about Sentry replays is that you have every single action that a user did on that page, every single thing they clicked. And of course, because you've got all of the Sentry metadata as well, what browser they're in, what OS they are on, whether they're on a mobile or a desktop, you have everything you need technically to diagnose this issue and get the fix out a lot sooner rather than messing about with recreating it locally. You can play the whole replay. You can see how long it is. You can see everything they did. You can see what their mouse did. And you can scroll down this list and see absolutely everything they navigated to or clicked. And again, most importantly, you have this trace view next to the replay as well. So if you click on the trace tab at the top, you have everything that happened in that trace.
Oh, there we go.
Where the error happened. And it even plays that little line, the playhead, as the video is playing, as the replay is playing. And like, you don't need any more than this when you're trying to diagnose something in the middle of a fire and checkout's broken and the CEO is sending angry emails saying we're losing money. And I think that's such a valuable thing. And what you've noticed is that everything is connected to the trace. The error has the trace. Performance data has a trace. Replay connected to the trace. Everything's about the trace. And it's changed my life. I mean, it sounds a little bit extreme, doesn't it? But this just, as a front-end developer, this gives me so much visibility on the systems that I won't touch day to day. And I don't need to touch them. I don't need to clone the backend systems, spin up a local database, which scares me, and try and replicate these issues. Everything's here for me, and I can just get fixing. I think we have some more questions.
Thinkwers ask, is this built with a screen capture API? No, it's a DOM recorder. That's why I can do right-click, inspect, and even inspect the little player thingy, you see? It's literally just DOM. Just DOM. That's it.
Okay. Questions. All right. These are great questions.
Can we get this data for mobile apps? I see one in YouTube. For mobile apps, we're working on because there's no DOM in mobile apps. We're working on something that utilizes screenshots. So it's not going to be like an actual recording, but there's going to be like a breadcrumbs of screenshots basically.
Okay, so one question, and it's an interesting question because it is a good question. By how much does all of this tracing slow down backend and front end performance with tracing versus no tracing?
Yeah, I would say not enough for you to notice. So technically, you're adding, in this case, you're adding JavaScript, right? Sentry's SDK is JavaScript, and in order to function, you need to invoke that JavaScript. So, you know, it does contribute to more JavaScript being executed, but we use Sentry inside Sentry, like inside here, and we've never actually gotten any data that, you know, the SDK itself pushed the performance, you know, across the red line. So we've never seen that. And if that's the case, then maybe the performance of your site is like too bad. So that one little, you know, the SDK itself is just gonna tip the whole tower over. But the good thing is that using the SDK, yes, it will increase the, you know, it will contribute some load to your website. But then using the SDK, you will cut down in all the data, right? You will cut down on that load. So it's like, you know, it's good to have it, but it's not noticeable.
Yeah, my camera's turning back on. I'm so sorry about this. My opinion is, so as a front end dev, you know, I've got Sentry on my front end on my website, and it's interesting that Sentry is identified by Sentry as the resource that takes the longest to load.
Yeah.
But that means actually that I've got no other resources that are taking anywhere near as any of that to load. And so my site's pretty good, right? My site's pretty fast, and Sentry helped me get there. So I think I'm willing to pay that price. It's not a huge bundle, right? But I think, but like Lazar said, the benefits of having the tool outweigh that. And you know, actually, I've got a blog post out that's coming onto the Sentry domain in the next week, and actually, performance, when you're talking about speed, when Google ranks your core web vitals, is actually not as much about pure speed as you would think. It's more about usability, and the thresholds for pages loading and actions happening, they're not actually they're not in milliseconds, they're in seconds. And so you don't need to be as fast as you think to create a good experience. It's about making it usable. So there's give and take there. For trace views, are there ways to anonymize input fields, for example, passwords or social security numbers? We don't,
What was that?
Is there a way to anonymize input fields for the trace view?
For example, passwords or SSN.
Yeah.
We need to see this in action, but Sentry implements data scrubbing in both places, in both levels, on the level of the SDK and then on the level of the backend. So there's PII being scrubbed everywhere, right? So you can see all of these stars right here.
That's
Those
not even PII, but it's still
being captured. It's like, yeah, by default. But there is a way for you to manually opt in or like manually opt out of PII scrubbing. Like for example, if you hit inspect here, you're going to see that this span has a sentry-unmask class name, so that it doesn't, you know, so we can identify that this is the add to cart button. This is not PII. That's it, right? So yeah, you can manually opt out of PII scrubbing, but it is the data that's being transferred between the Sentry instance and the SDK itself is scrubbed in both levels, on both levels. I guess we're almost at time, by the way.
Oh, we are. Oh, we got 2 minutes left. Right, we have so many questions. So I think actually what we need to do is you need to come and ask your questions in the Discord.
Yeah.
Where we have loads of people ready to help, loads of people who are using Sentry already. discord.gg/Sentry. It's such a very active Discord. There's chat going on. You can submit specific questions in the help forum as well. So
you'll chat with the engineers themselves, the people who
exactly.
work on Sentry.
Yes. And if you want to try Sentry out, if you are curious about how this could work for you and how you can visualize your traces between all of your applications, you can get a 14-day trial at sentry.io/sign-up.
Beautiful. And we did mention at the beginning of this event that we're dropping something cool today. Yeah. We're releasing the beta versions of the brand new trace view today in like a couple of hours, I think. So keep an eye on our blog or keep an eye on our social platforms because that's going to be pretty cool. You don't want to miss that.
I'm excited.
Yeah.
I'm excited. All right. Thank you, everyone, so much. Thank you on YouTube. Thank you on Zoom. Really great questions. Thank you for all your participation. And I've really enjoyed hanging out with you and nerding out about tracing. And remember, it's not about front end and back end. It's about joining everyone together.
Exactly. Yeah. Awesome. I hope you had fun, all of you. I hope we answered most of your questions and you understand what tracing is and like how to use this tool for quality of life improvements. So